Hi everyone, welcome back to CI Math 389. Now today we're gonna talk about probability. Now first of all, I wanna talk about some definition of probability. An experiment is a situation involving chance or probability that leads to results called an outcome. An example, the experiment is spinning the spinner. So we do the experiment for spinning the spinner, okay? And then, what does outcome mean? An outcome is a result of a single trial of an experiment. For example, the possible outcome are landing on yellow, blue, green, or red. So that would be the outcome. Next term is called events. An event is one or more outcome of experiment. For example, one event of this experiment is landing on blue, all right? And what is a probability? The probability is the measure of how likely an event is. An event is, okay? So we know the event is what? Is one or more outcome of experiment. So we'll measure how likely an event is. For example, the probability of landing on blue is 1/4, right? So now here is a probability, here is a formula of probability of an event. So we take the number of ways event can occur divided by the total number of a possible outcome. So here is an experiment. A spinner has 4 equal sector, color, yellow, blue, green, and red. And now after spinning the spinner, what is the probability of landing on each color, right? So the probability, let's say yellow, okay, probability of yellow. Probability of yellow, and which is equal landing 1 chance of the events, all of the total, which is 4. So 1/4 for 1/4 for yellow, okay? Now what is probability to get blue? Probability to get a blue. So the total is 1, and no, the number of ways events can occur like blue is 1, and then the total number of the possible outcome is 4, so 1/4, right? Similar for red, probability to get a red, 1 out of 4, right? What is the probability to get green? Again, the events, we can have 1 for green, and what's the total amount, which is 4, okay? So that's probability formula, okay? Now, what about this? Experiment 2, a single 6-sided die is rolled. What is the probability of each outcome? What is the probability of rolling an even number, of rolling an odd number, right? So probability to get a 1, which is 1 out of 6, right? Probability to get a 2, which is 1 out of 6, right? Probability to get a 3, which is 1 of 6. What about 4? 1 of 6. Probability to get 5, 1 of 6, right? Probability of 6 is 1 out of 6, okay. Now that's the for each outcome. Now next, I'm going to answer the question: what is the probability of rolling an even number? So probability to get an even number, which is even number. Even number the event, we gotta have a 3, right? And what's the total? Total is 6, right? So therefore, we have 1/2. Now, what a probability to get an odd number? Again, the events we have is 3, and then total outcome we have a 6, so which is 1/2, right? Okay. Now next, single event. A single event involves the use of one item, such as one card being drawn, one coin being tossed, one die being rolled. For example, from a normal deck of 52 cards, what is the probability of choosing the queen of club? So the deck contains only one queen of club, so probability will be 1 all over 52, right? The total is 52. And what's the chance to get 1? 1. So therefore, 1 out of 52, right? Next. A compound event involves the use of 2 or more items, such as 2 cards being drawn, 2 coins being tossed, 2 dice being rolled. So here is an example for a compound event. Amy has 5 tank tops, 3 pairs of jeans, and 2 pairs of sneakers. How many different outfits consist of one tank top, 1 pair of jeans, or 1 pair of sneakers are possible? So we are using what? The counting principle. We take a 5 times 3 times 2. When it comes to the compound event, we use the counting principle. We take a 5 times 3 times 2. So therefore, the total, how many? 30 outfit, okay? The independent event. 2 events, A and B, are independent if the fact of A occur does not affect the probability of B occurring. All right. So we use the multiplication rule. And when 2 events A and B are independent, all right, because they does not affect to each other, right? So we will use the multiplication, okay? So if we have a probability A and B, and then we take a multiplication, probability A times probability of B, okay? So this is independent events, okay? So let me give you some example of this. Here is an independent event, right? 15 coins and rolling a dice. They are totally independent. They are affect to each other, right? So therefore, we can do independent event like this. So a coin is tossed, and then the single 6-sided die is rolled. Find the probability of landing on the head of side of the coin and rolling a 3 on the die. So in this example, we want to do, because we were actually, we're looking for the head, all right? Probability, the head side of the coin. So we have a head. And then plus probability of what? Of a 3, right? So therefore the head and 3, right? Probability of head. And then we 10 times the probability of 3, right? And what's the chance to get a probability of head, which is 1/2? Makes sense to you? How about probability of 3 is a 1 out of 6, yes. So therefore times each other, 1 out of 12. So that will be, the answer, okay? Next problem. Independent events. A card is chosen at random from a deck of 52 cards. It is then replaced in a card, and the second card is chosen. What is the probability of choosing a jack and an 8? A jack and an 8. So in this example, we want to find, what's the probability of Jack and 8. So therefore, we take a probability of J times the probability 8, right? So what's the J? J actually is 4, we have a 4 Jack out of 52, right? Times another 4 8 out of 52, right? For normal deck of cards. So therefore, actually we can reduce this first. So we reduce this, we'll get 113 times 113. So therefore, is 1 of 169. This is the problem, how we solve, okay? Next, suppose we are tossing a fair coin 3 times and record the result. Find each of the following: the sample space for the experiment, the event A of tossing 2 heads and 1 tail, the event B of tossing no tail. So first of all, we have to find what's the sample space for this. Now sample space, because we toss how many times? We toss 3 times. So 3 times. So the first time, you might get head or tail, right? And then the second time when you toss, you might get head or tail. You might get head or tail for this, right? And then third time you toss, you might get the head or tail. And head or tail for this. And head or tail for this. And head or tail for the third time, right? All right, so now we have many possibilities. We have the sample space is head, head, head. Did you see it? Head, 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 right? So here we have, and then we have head, tail, and then we can write it down all the possibility, So 1, 2, 3, 4, 5, 6, 7, 8. We have 8 possible outcome, all right? So we might have head, head, tail. We might have head, tail, head. We might have a head, tail, tail. We might have a tail, head, head. We might have a tail, head, tail. 1, 2, 3, 4, 5, 6. We might have 2 more. Tail, tail, head. And tail, tail, tail. So we have, this is called a sample space. We have 8 different kind of outcome, right? So now I'm gonna answer the next question, okay? The next question is the event A of tossing 2 heads and 1 tail. The events of tossing okay, so I'm gonna change the color here, you can see, okay? So here, how many chance to get 2 heads, all right? And 1 tail, 2 heads. See, this is 2 head. 2 heads. 2 heads. We have head, head, tail. We have tail, head, head. We have head, tail, head. Oh, we have how many? We have 3 possibility of this for 2 heads and 1 tail. So 3 out of how many? No, the sample space is total is 8. So the answer will be 3, 8, right? So the events of 2 heads is, the events of this, head, head, tail. This is called events. This is called event, not probability. The probability give you a number, all right? They give you a number. So this is answer would be the events. We have to write it down. Head, head, tail. We have head, tail, head. This is called the events. Tail, head, head. All right. So this is called events because the answer the question for events, right? Now, if I ask you what is the probability? Every time X of probability, you give a number, right? But event, you don't give number. Event just show what's the possible outcome, okay? So probability, this will be the probabilities, 3, 8, right? Okay. And what about event of tossing? I can give you different color. What's event of tossing, no tail? All right, event B, tossing no tail is only one. All right, so the answer will be H, head, 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 head. So that's one, okay? That is the event, okay? Now, if I ask you, what is the probability of getting no tail? So you will answer 1 or 8, okay? All right, so now, next problem. A golf bag contains 2 red tees, 4 blue tees, and 5 white tees. What is probability? Okay, now this time, see, the question is from the last different from last time. The last problem ask you what's the event. So this one give you probability. So you need the answer. You might give the number. Okay. So what is the probability of the event R? So what's the probability event R that T drawn at random is red, all right? Drawn random is red. So we take a 2 plus 4 plus 5, which is equal how many? Which is 11, okay? So that's the total outcome, all right? And what is probability to get the event R, which is red? 2. So the answer will be 2 out of probability of ray, which is 2 out of 12, 2 out of 11, okay? And then what next? Not R, not R, not ray. So therefore we got 11 minus 2, which is 9, right? So we have a 9 out of total. How many for total? 11, right? So this is 9, 11, okay? What is the probability of the event that a T drawn random, either red or blue, which is, that is the, either red or blue like this, all right? So therefore, we have to find it now, either red or blue. So this time we take a probability of red plus probability of blue. What is probability of red? 2 out of 11, right? What is probability of blue? Blue is 4 out of 11. So therefore we got a 6 out of 11. All right. Okay. The next problem. Okay, in this figure, shown a box with 11 letters. Some letters are repeated. Suppose 4 letters are drawn at random from the box one by one without replacement. So without replacement. What is the probability of outcome for BABY with the letter choosing in exactly the order given? Okay. So in this example, you can see, we want to find the probability of a BABY, right? So B, A, B, Y. And then we want drawing from here, right? From probability here, right? So what is the chance to get a B? How many B are there? 1 and 2. So I have 2 out of total. Total, how many letters there? Total, I counted there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 2 out of 11, right? Then next, what is A? A, we only have 1, right? Now here, without replacement, that means the next drawing is not 11, it will be 10, okay? And next, what is the probability to get a B again? All right, because a B already drawn, so therefore we have 1 left over, right? And next, chance, the outcome will be 9. It will be 9, right? Now next, Y, how many Y are there? How many Y are there? Oh, just only 1 Y, right? And what's the total? Because once you draw, you don't replace, right? So next will be 8. Make sense to you? Now, what is the combination of the total of this? All right. So actually, we times each other. All right, times each other, and you should be able to get an answer for this. Times each other, and you will get a 2 out of 7290, and we have to reduce this. Reduce this is 1 out of 3960. Okay, so this is a chance we can get a BABY. Okay, this is how likely the chance we will get a BABY. Okay. All right, I hope you enjoy this video today, and you have a wonderful day. Thank you.